Hi, and welcome to the first Create with Code tutorial. We're doing the very first project in Unity's Create with Code curriculum called PlayerController. And this project is really meant to be an introduction for you to get used to some of the language and the way the editor works and so forth. So I know we just completed an introduction project together, and I introduced some concepts there. But here I'm going to slow it down a little bit and take time to fully develop some of the ideas and give a sense of where we're going to be going. So let's just go ahead and get started with making the game. In Classroom, I will give you a link to a package that you'll download, and I will help you download that in class. And I would prefer you have it on your desktop. You'll know that it's a package because it'll say, package here, and it'll have that little Unity icon on it. And I'm going to go into my Unity Hub, and I'm going to create a new project. Now, sometimes when you open this up, it may take a second to load up these templates. That's something new to the newer Unity Hub. I don't really like it so much, but it doesn't matter. Give it a second if you need to. And I would just prefer if you click on, let me close this right here, the location. There's 3 dots here. I prefer if you went to your desktop and then create a new folder, or you don't have to even create a new folder. Just hit select folder. And I'm going to call this one, for me, I'm calling it Create with Code Player Controller. And actually, I'm going to call it Create with Code 1, uppercase I. I can't put a semicolon there. I'll create a little space. And I will hit create. I did this so that I can easily find my project. This is the folder that contains all of the parts of my project inside of it. So essentially this is my game until I build it out. And I put it on my desktop to make it easy for me to find. Sometimes when you first create a project, you won't be able to find it in Unity Hub. So it's nice to have it right there. Once we get a loaded scene here, I'm going to sort of expand this to make it a little bit easier to see. I know that some of you are having issues with getting Visual Studio to be your main script editor. So I'm going to go up to Unity, Preferences, External Tools, and change this option here to make sure it says Visual Studio for Mac. You might already have this. I'm not sure why it's not staying consistent for everyone, but please go ahead and check that. I would just do that out of habit now, as of now, for many of you. So when we first come in, we have our hierarchy set up, main camera, directional light, all this. Our project area, you should see assets with a scenes folder. And out of habit, what I tend to do is I take my game, I go to my game window, first thing I almost always do, change it to 16:9 aspect. And I like to take the game tab and holding it down, I'm going to drag it. And you can see it sort of snaps to like different locations. I'm just going to drag it over here to sort of the right side of this panel so that I can see my game view while working inside of my scene. And I can just drag it back over if I can drag it in a lot of different ways to kind of get it where I want it to be. If you find that you don't like the way the layout's working, just click on layout and go back to default. But this works for me. This is my preferred layout. Pretty simple setup there. So before we start, I already have built a scene for us to work in. And for each of these projects, you're going to have this package. And this package is basically another game that you're going to put inside of your project. The easiest way to import this is just to take this and drag it into your project area. It'll give you this dialog box right here. Will list everything that is inside of that package. And I want you to go ahead and import everything. So click the import button. Boom, and give it a second to do so. Shouldn't take too long because this is a very small package. On the console, you might get a few warnings here. I wouldn't really worry about them. You can hit clear even if you want to. Not that we should totally ignore yellow warnings, but yellow warnings, I will let you know there's something that we need to deal with. Sometimes they don't really interfere with our game. They're small things that we don't need to concern with. It's the ones that are red that in our console that we really need to be wary of. So back in project, you have this folder now called Course Library. And if you go inside of it, there's a bunch of things already pre-built for you. Let's step out. I think in scenes, so go back to assets, go to scenes. The sample scene is currently what we're in, the one that we automatically loaded when we first came into the game. But I want you to work inside of the scene known as prototype 1. So double click it, and it should open up this scene. And I'm going to click on my sample scene, control on my keyboard, right click, and hit delete. It will ask me if I want to delete that sample scene. I'm reading that right there. Make sure I'm on the right thing, and I'll hit delete. So that way, when we load our game up again, this will be the only scene that is available, so this will be our default scene. So currently, your default scene, I'm holding down Option on my keyboard to rotate my camera, has a sort of fake sky dome. You have a sky dome, and then you have a little skybox, like sort of ground skybox, and we have a road. And I can click, zoom on any one of them in the hierarchy by double clicking on them. And if I want to hide them, I just shutter them using this little triangle right here. So let's go ahead and drag our vehicle into the scene. Assets, course library, vehicles. When you first come in, it might be blue because they're prefabs, but give them a second, they'll load. And you have a couple different vehicles available to you. I'm going to go with this truck. There's two ways to add this to the scene. I could just drag it into the scene. The problem with that is, if I do this, it just puts it in a random position. So I'm looking at my inspector and I notice that the positions is rather random. I can automatically snap it to 0, 0, 0 by either typing in 0, 0, 0 to place it at the beginning of my road, or I'm going to hit Command Z to undo that. There's these three dots on my transform that I can click, and I can say reset position. I can also later on change my rotation and stuff with these buttons here, and that will snap it to 0, 0, 0. The final way of doing that, I'm going to delete my truck, is I could just drag this into the hierarchy, and it will automatically put it there. I find that it's more consistent and it's a little bit easier to deal with at points to drag something into the hierarchy so that it goes to 0, 0, instead of me having to take those few extra steps and try to find it or place it somewhere. Let's take this truck, or this vehicle, and in the inspector rename it to capital P player. It's always good to note where your player is. So let's look at the player and what components it has on it. It has a transform, which tells us its position, rotation, scale. It has a mesh filter. We don't really need to talk about that right now. Mesh renderer, which available and disabled. We've done this before, where it turns on and off what the truck looks like. I would like for you to note that the wheels are not turning off because you'll see that they are their own objects that are a child of the player. And so if I turn off the mesh renderer on the parent, it doesn't mean that the mesh renderer turns off on the child. I have a mesh collider. Because our truck is not a regular shape, the collider that comes with it has these different angles, and that's known as a mesh collider. And for most games, you don't even need to do that. We could just put a box around it, and that would be fine for what we're doing. So I'm just shuttering these so you can kind of see what's going on. So we have a player in the scene, and we have it set to 0, 0, 0. And add an obstacle. So right here in the projects area, I can either go back to other folders by using this left-hand panel. So I can go back to course library this way, or I can click on their names here above. I'd like you to go into the obstacles folder, which is a child of the course library. And I'm going to drag a crate into the scene. I'm going to drag it into my hierarchy, as we talked about before. And you note that it will go to the 0, 0, 0 position, which is inside of our truck, not where we want it to be. So I'm going to change this position. I'm just going to give you, well, first, actually, I'm going to change the name, and I'm just going to call it OBS. That's just my shorthand for obstacle. I could also call it crate, and that's fine too. Either way, works for me. The position on the X, I just want to move it forward. So we know that the left and right axis, which is denoted by this red arrow, is the X. And so if I drag it, I can see that my X position is changing in the transform. I don't want it to go left and right, I want to move it straight ahead. So we can tell from here that that is our Z axis. I'm just going to move it forward to 25 on the Z. Press return. And sure enough, our crate is in front of our car. We also want to make it so that our camera, so if I click on main camera in the hierarchy, it's off to the side. We would like to have it kind of like our first project right behind our player. So I know that I want my Z to match up with the Z axis, so I need to rotate. I could either come up here to my tools. So Q is our move tool, W is your transform tool, and E is your rotate tool. Those are the ones you typically use up here. I can either grab the handle to rotate it, and we'll talk about this rotation, by the way. The color is important for our rotation. We can rotate it using this, or we can use our transform to do so. So right now when I rotate this, it's like rotating multiple angles here. It's like our camera's not straight. I'm mainly rotating it, if I go to my W, on this Y-axis. The Y-axis goes up and down through this camera because I'm choosing the axis which around I'm rotating. So even though I'm moving it left and right, I'm not rotating it on the X, I'm rotating it on the Y because I'm going around the Y-axis. So I think the easiest way to do this is to rotate our camera. I think our position need to be 0 actually. And there you go. I don't know why the rotation on the X is 5, but I'm going to set it to 0. There you go. That kind of cleans it up a little bit. All right, let's move the camera. I'm just going to use the handle for this. It's sort of here on the X. What if I move the X to 0? There you go. X of 0. And Y, instead of 5, I'm going to try a -5. Move it back behind the truck. And then I want to lift it up. So 2 looks like it's a little small. What about 4 on the Y? I think that looks okay. If I wanted to see more of my truck, I would move it further back, so -8 maybe. And I like the way that looks. So our camera is positioned behind our player. Now we've noticed before that having our camera as a child of the player isn't so great. So we are going to make a script in a minute to help manage that. So I'm going to save this. Remove my component. I don't know what that issue was. All right, so save this again, Command S. All right, so the main feature of this project is to get you used to using a player controller. So let's go ahead and build a script for that. Over here in project, hit the plus symbol. Let's create a new folder, and we'll call this scripts. The reason why we use folders is it's so important to stay organized. And I know you hear this all the time from teachers about different things, and maybe you naturally are organized, and maybe you're not. I'm not an organized person by nature, but it really makes a big difference when you're keeping your stuff organized within folders. If you create a pathway, it makes game development so much easier. I won't say much beyond that. Please try to get comfortable with using folders. If you accidentally create one inside of another one, let's say you create it inside your scenes folder, then go find it over here in the left panel and then drag it into the folder that you want it to go. And it'll move back to where you need it to be. All right, I'm going to go into my scripts folder, and I'm going to create a new C# script. Let's say when it first comes in, you press enter, you accidentally create a script without changing the name. The name will be locked into the script. If you first initially do this, you'll notice in the inspector that it will inherit the name that you gave it. But if you go back and rename it, control right click, rename, let's just call this one help, you'll notice that my script name didn't change inside of the script. So these two scripts are not connected anymore. So it's really important that you get your name right the first time, or you have to go back into the script and try to edit it. It's just easier to go ahead and just delete the script and try it again instead of trying to go into your script and edit it. So I'm going to, with the script selected, I'm going to hold down Control on my keyboard and right click. And I get this panel again. I'm going to hit delete. Delete that script. Give it a second. And instead I'm going to create a new C# script. And the name of this one is capital P, Player, capital C, Controller. No space. That is so important. No space. So check this before you press return. Player, Controller. Then press return. And it should make us a new script with the name Player Controller right here. Double click it to open it up inside of Visual Studio. And out of habit, it's really good to just look at the name of your script one more time and make sure that's what you have on your line 5 where it says public class player controller. Every once in a while we will come up here to this top area and change this, but it's going to be very rare that we do. So everything that is inside of this script is in these brackets. So line 6, for me, 18. So I'm never going to type below this lower bracket. Ever. Ever. Never going to happen. And then we have these methods that are contained right here. Line 8 is a void start method, 8 through 11. Everything I want to happen when the game starts is going to happen in between these two brackets. Everything I want to happen every frame happens in these two brackets, line 16 for me. A method is basically a series of actions that are taken at a certain point. Usually the name of the method is when that thing occurs, or a name that you can call it to make it show up somewhere else. So in the start, everything between these brackets will occur. It's either like making an action happen or you're adding some numbers together, anything like that. So a method is where the things happen in the script. But for those things to happen, we have to have references to things that are inside of the game. We have to hold numbers, we have to have game objects and all that. And that's where variables come into play. So line 6, let's make it a variable really quick. I'm going to go to line 6 because I want to be inside of these brackets. I'm going to press return. I might press return again just to create a little space, and I'm going to go back up to line 7 for me. I'm going to create a public int known as player speed. So there's a lot going on here. Let's pause here for a second. A variable is a container that contains a piece of information that we can use in our script. This variable is a public one. I'm going to save this for a second. I'm going to go back into Unity, and we know that this script is going to go on our player, so I'm going to go ahead and do that now. Take my player controller. I can do it two ways, and actually the way I think I'd like for you to do it, get in the habit of doing, is instead of dragging it onto it, click on your player and just hit add component and type in the words player controller, and you should see your script over here. If it doesn't, and if you have a red error over here, that means you forgot something. So let me give you an example of what that looks like. So in Visual Studio, let's say I delete my semicolon at the end, I'm going to save that. I will get an error. And the way that I read this is, in my assets folder, actually tells you the time that you got the error too. So I'm recording this at 12:28. So in my assets folder, the scripts folder, the player controller.c# script, line 7, 27 spaces from the side. Then there's an error code, which you don't really need to worry about. And then there's a semicolon is expected. So line 7, 27 lines over. And sure enough, line 7, and this is about 27 over, I'm missing a semicolon. So save that. So if you have no errors, you should then be able to add your script. So player speed is public. And public means that the variable can be seen in the inspector. And there's a lot of ways we can manipulate that, but really we like to do this on some scripts if we want to change those values here in the inspector. If not, it's a good idea to make them private And private means I would not be able to see it. So if I come back in here and I made this private, if I never wanted to change the speed at which my player would ever be able to move, I'll save that. And you'll see that it'll disappear under that player controller script. Gone. But for this example, we want it to be public, so we can play with it some. So public int. Now there's a lot of different types of variables. An int is an integer, a whole number. So 0, 1, 2, 3, 4, 5, -7, -12, anything like that. There's also floats. Floats are decimal numbers. So speed typically would be a float. I just happen to make it an int for the sake of our game. But float is used a lot, especially with things like time. When things have a lot of small units, we tend to use floats. We also reference things like game objects. Oops. You know what? I gotta learn how to spell. Oh, is it capital O? There it is. That should be it. So I can hold a game object as a variable. We've looked at true or false statements, also known as booleans. So public bool. We can even reference components, things that are attached to our player. So rigid body or mesh renderer. So all of these things are referenced. We can even reference scripts, which we've done before too. So note that variables are what hold the information that we're going to use. And then the way that we name them is always something called camel case. Lowercase for the first word, uppercase for every word after that, and then no space. So player speed number would be, I had a whole thing highlighted, would be proper camel casing. Because every word after the first one is capitalized and there's no spacing. This would be incorrect. So I'm going to stay here with player speed. All right. So then we have to ask ourselves when I save that script, by the way, Command S. I want to ask myself, when do I want to have the player move forward? And then how do I do that? Well, the first way to do that is to, I think I want to do that every frame. I want my player always moving forward. So I don't want this to be in the start method. So instead, inside of the update, line 18 for me, I'm going to put the component that I want to use on the player that will allow it to move forward. For this game, we're not going to do what we normally should do. Normally, we use a rigid body to add a force and push our player forward. We did that in our last game. For this game, we're going to simplify it a little bit because I want to explain something, an idea that's relevant for us later. So instead, the other way I can move my player is using its transform. I can just force it to move by basically dragging it through the world. Instead of adding a force, I can just say be there, force it to be there using a script. And so the position, transform dot position, and then the axis I would want to move forward, well, we know that's the blue one, aka our z-axis. So the way that we script that is we're going to say take the transform of the object that this script is on, which is our player, dot capital T translate, and then open up an argument, which is shift 9. And when I do that, you'll see that I get a vector 3 translation. And we're going to talk about that in a second too. Currently, I need to write in some numbers to say which direction I want to move. Do I want to move on the X? Well, the answer to that is no, comma. Do I want to move on the Y? The answer to that is no, 0, comma. Do I want to move on the Z? And yes. And for now, I'm just going to put in the number 1 and put a semicolon at the end and save that. And I would like to go test this out. Now, we did make an integer called player speed. We're going to replace that in a second. But let's just test it out and then come back. I'm going to press play. We already have the script on it. And it just zooms ahead. But it works. You notice that it did not respect the collider that is on our crate. Our crate does have a collider, and our truck should have hit it, right, and stopped. That's the problem with using the transform to move an object instead of the rigid body. Rigid body will respect colliders, and you will respond to it. A transform.translate doesn't care about the thing that you're hitting, which can really kind of mess up your game in some ways. All right, let's go back into that player script, that player controller script here. So one is really fast. And we've talked about how we never want to put a number, like a hard number into this spot. So instead, I'm going to delete that one and put player speed and save that. And that's the more appropriate way of doing that. So let's go test this out. If I save it, now this won't run. I'll press play, but our player won't move forward. It's because in the inspector, since I have it as a public variable, it says 0. I need to increase that speed like that. And you can see it just zooms away. Now, you notice it didn't save my number because I was in play mode. So I'm just going to put a 1 here. Save that. Now, it should move like it did earlier at that rate. Get out of play mode. But that doesn't move the, well, let's fix this first too. Let's talk about vectors. This, instead of me typing out 0, 0, and then a z value, there's something called vector 3s. Vector 3 just says, on what axis do you want to apply a force? And it gives it a nickname. It's got 3 vectors because we have x, y, and z. So for this, there's a direction we want to go. So I'm going to delete this section here. So transform.translate. Let me just actually delete all this argument. Let's just start fresh here. And I'm going to say vector 3, period. And it'll ask me which direction do I want to go. And I have backwards, forward, right, up, and down. So forward, it basically is the same thing. I'm going to go to the next line. You don't have to type this. I want you to see. It's basically the same thing as 0, 0, 1 because it's moving forward on the z-axis. If it was a vector 3, let's say, dot up, I bet you can guess that it would be 0, 1, 0. If it was right, then you would know that it would go 1, 0, 0, because it's choosing the x-axis, left and right. If I want it to go left, then it would basically change that right to a -1. So that's what a vector 3 is. It just basically converts our XYZ direction into a shorthand piece of code that's a little bit easier to manage. So knowing these vector 3s is really, really important. So I'm going to delete my comments here. We don't need those. I just wanted to show you that. So I want to go vector 3.forward. And vector 3.forward also wants to know, it knows that this basically sets our speed to 1. But I'm going to give us control again. So we're going to multiply this, shift. And I want to control our player speed. So I put in player speed, the variable. And then the last thing I want to do is we've talked about this thing called time.delta time. And time.delta time essentially just says that it takes sort of real time opposed to the computer's processing speed to calculate speed. What that really means is you have this thing called update that we're in. An update happens every frame. And there's the beginning of the update, there's the end of the update, and there's gaps between them. And the gaps are typically determined by your processing speed or the frame call. The update comes from how quick your computer is. But with time.delta time, the gaps between are always set to a real time, I guess is the only way to say it. So the point is this. We're going to use time.delta time the gaps in between that are always consistent to make sure we have a consistent running rate. And if I save that, you're going to notice that your truck's going to go considerably less quick. Where did that? There it is. Okay. So now that my player speed is 1, I'll press play. And you'll see that we go a lot slower. But we are moving forward on a vector 3.4 direction. 50. That's probably too fast. I think, I don't know, something, maybe 25 is the way to go. Maybe even 10. Let's just try 10. I want to go with a lower number because we're going to be trying some obstacles and stuff. I want to go with 10 for now and save this game here. So we need to have our camera follow our player. So I'm going to go to our main camera here. And yeah, I apologize. Let's go to projects folder. And you have a script folder. Let's hit plus, new C# script. And we're going to name it like we did our last game. Follow, capital F, player, capital P. No space. Looking at it, looks good. Press return. Checking the name here. And then double clicking to open that script up. So in Visual Studio, you have some tabs here. Just make sure that you're on the right tag. You're not on your player controller. Have it on your follow player. So our follow player script is going to be pretty simple. We want to know where our player is, and then also make it so that we're not sitting right inside of the player. I don't need to do this at the start. I want to do this every frame. So I want to get rid of my void start. So make sure that you get rid of these two brackets and then the word void start. And you can even get rid of the comment as well. So that's the part I'm getting rid of. I'm just going to hit delete. So the variables I need are a public. And since I'm going to follow my player, I can just look for my player as a game object. Public game object known as player. Semicolon. And in our update, this is going to go on our camera, so we want our camera's transform dot, and the part of the transform we want to change is the position to be equal to the player dot transform dot position. But we already know that this is going to be an issue. It's going to put us inside of the player. So let's add an XYZ thing in our inspector that allows us to change how far away we are from our player. So end of line 7, I'm going to make a public, and XYZ, the shorthand name for that is vector 3. And I'm going to call it offset. So how far from the player, how offset are we from the player? Line 13, I'm going to add that to the player's position. So take the player's position, then add whatever values we give it in the inspector. Save that. It is saved because I see a little X here. Go back in Unity. You might need a chance to compile. And this script is going to go on our camera. So main camera, add component, and I'm going to type in follow player. And if you're able to add it, that means you have no errors in your console. If not, go back and look at that other script. It wants to know where the player is. So take player, drag it into that slot right there. And this is how far away from our player we want to be. Right now, if I press play, the camera is going to be inside of the player. Not great. And you're going to see this sort of jumping motion. We'll talk about that in a second. I want it to be up higher than the player, so I'm going to use what I currently have in my, we liked our camera position. So I'm going to go position of 4 and a position of -8 on the Z. And that'll keep our camera in the same position as we have it set right now. There you go. Now we have this sort of jumpy camera thing going on. And the reason why that is because update right here has, at the start of the update and the main part of the update and then it has the late update, which is the end of it, and then you have a gaps in between, which is where time.delta time exists. Our player controller, you'll see that we're moving in the update, but we're also telling our camera to move in the update. So the camera is trying to move at the same time as the player, but the player is moving away at the same time, and that creates this jumping motion because the camera can't quite keep up. So instead of doing it during the main part of the update, line 11, I'm going to change it to late update. Late update is typically done for cameras or things, like you usually use the update for physics or moving an object, and then the follow player script is usually like for cameras, things you want to happen right after that. So if I save that, you should see that our jumping camera will kind of go away, and that moves a lot smoother. Once again, mind you that our crate, the collider is not being affected only because we haven't used rigid bodies or anything like that. So let's do that now. On our player, I'm going to add a rigid body. And on our crate, I'm also going to add a rigid body. And for this, let's make our player have a mass of 2. Let's make it more massive than the crate so we can push it around a little bit. And I'm going to save. Let's see what we get now. Boom. And the crate just goes right over. Perfect. Done. Let's go ahead and take and duplicate some of these obstacles. So crate. And with that selected, I'm going to hit Command on the keyboard D to duplicate. And now I have crate 1. And I will just move this one. Since I press W on my keyboard to make sure I have my transform tool on. And I can move this crate out. And I can hit Command D and just start laying some of these out, sort of to make, just a basic obstacle course, as we've done already. Make sure your camera says perspective. If you click on it and you hit isometric, your game's going to be a little weird, right? We want to keep it in perspective mode, just in case someone accidentally clicked on that. Just want to mention that. So I'm just going to lay a few boxes out. Now, this isn't much of a game right now, because if I press play, I can't press left and right. I don't have left and right controls. I can't help but hit boxes, only because I can't move left and right. So let's add left and right controls. On your player, you have your player controller script. Double click it to open it back up, or just go into Visual Studio and you can find it. And I want to do player controls inside of my update because I want to be checking for them all the time. So let's also do a transform.translate. So I'm going to go to end of line 18, press return. Transform.translate needs an argument, and I'm going to go ahead and put a semicolon at the end of it for now. So when we turn left and right, or when we move left and right, well, we know that we need to use a vector 3. So we're going to say vector 3. And dot, if we're moving left and right, we're going to use the right axis, right. Whatever number we go with, the negative version of it is going to be left. So we only have to do this one time. Times, and we want this to be a whole number, right? Or, yeah, actually, I'm sorry, I lied to you. Let's go with... No, yeah, we can go with a float. Let's try something different. Line 7, press return, public float, and this will be called turn speed. 2 words, so it's lowercase t, capital S, semicolon at the end. And we want this to be multiplied by turn speed down here. If I save this, I bet you can predict the problem with this, is that we're always going to be moving right no matter what, because it just happens inside of the update. If we go into our inspector and change, let's change turn speed to something like 3. You're going to be moving forward and right at the same time. And because we didn't use time.delta time, we're going really fast going right. So we need to make it so our player has controls, and we're going to use time.delta time to make it consistent. So I'm going to go ahead and add that time.delta time right here. So line 21, inside of that argument, times time dot delta time and save that. Just go back and check it one more time. Press play. There you go. But I don't have left and right controls. So inside of Unity, edit at the very top, project settings. We have a bunch of options here, and we're going to go to input manager, and there's axes. Left and right would be considered our horizontal axis. So these are all the buttons that are assigned. In our first game, we said input.getKey, and we named a specific key. But we also have pre-built axes that basically says, so let's look at our horizontal. It says left and right arrows are already programmed, and then the A and D arrows are already programmed. So it already gives us all our keys. Instead of us having to come up with all the different keys ourselves, we just need to put in the name of this axis that we want to use. And we want to use horizontal, left and right controls. But it has to be spelled exactly the way it's spelled here, with a capital H. You can't misspell this, because this is going to look for this name. If we were doing jumping, we would go to our vertical axis, and then we could use our up and down keys. But we're not doing that in this game. So I'm going to close this window, but knowing that I need to have capital H horizontal. So back in my script, the way that this works, it actually makes horizontal a number. It's looking for how much you're pressing a key down. So let's go ahead and just look at that. So line 8, press return. I'm going to go public float, and we'll call this horizontal input. Save that. In the update, line 19, I'm going to go put it right above, so right here. Create a little space. As long as I'm in between these two brackets and I'm still inside of the script, I'm fine. And I'm going to go ahead and say horizontal input is equal to input dot get axis. Open up an argument, and it needs to know the specific name. That's what it says right here, axis name. And this is where we put semicolons, quotation marks, because this is a specific name, and this is where we have to spell it like it was. Capital H, horizontal. Put a semicolon. I'm going to save that. So this is a public float. So what should happen is when I press my A and D keys or my left and right keys, I should be able to see that value right here on my script. So if I press to the right, you'll see, make sure I click on my window, it go all the way up to 1, but not past it. And if I let go, it moves in between that like some decimal numbers. If I go to the left, it gives me a -1. Same thing with D key and A key. So we have left and right controls, and that control is actually saved as a number between 0 and 1 for right, and then 0 and -1 for left. So I just need to actually use this number. I have the number, but I'm not using it inside of this. So I'm going to go, I'll just go to the end of the line, that's fine. After delta time, shift 8, that's how I'm doing multiplication, it's an asterisk. And I'm going to say the name of the variable, horizontal input. So now that I'm multiplying this, it's the right axis. I'm going to put a comma underneath, just look at this with me. So I'm going to say transform.translate. This is what it's doing, so don't type this out, I just want to explain it. It's taking a 1, it's taking the number 1 on the right and multiplying 1 times the turn speed, which for me was like 3, times time.delta time, and I'll just blank that out for now, and then times horizontal input, which is a number that's like, let's say it's +1. And this is why I have movement. It's 3 times 1 times 1, so 3 is going to move 3 only when I press the button. When I'm not pressing the button, horizontal input is 0, and this won't turn. So save this script. And what we should see is moving forward, and then I press the right, click on the window, and then right click, and then if I press left, I move to the right. I mean to the left. It's kind of slow, but that's fine. I'm just trying to work it out for you. All right. It slides, but we also kind of want the truck to feel like it's turning as well. So, by the way, never change your heart. You don't need to change your horizontal input. I made it public so you can see it, but don't actually put a number in here because that will mess up your game a little bit. Or it might. It actually should be okay, but I'm going to save my game. Let's make it so that our truck turns. Go back into Visual Studio. I'm going to delete that space here. So I'm going to leave some comments here. This is just for you to see. So I'm using 2 forward slashes. This is a really good way to keep notes to help you find things later on. I would encourage you to do this. I'm not requiring you to do it, but if you want to be good at game development, get in the habit of leaving notes to yourself. And you'll see in my future videos, I sometimes do it, sometimes I forget, but I know I'm a lot better when I leave notes to myself. And when I make bigger projects, I tend to leave comments. So the line below this horizontal input is finding the number that is connected to left and right controls, the float essentially. Line 22 is moving my player forward. Line 24 is moving my player left and right. Remember, we're using the transform, not the rigid body the way we were supposed to, but I wanted you to see vector 3s and all this stuff. Let's make it so our player only moves forward when we actually move him forward and then also rotates. Let's think about this. Yeah, we're going to use the vertical axis to do that. So line 9, this is going to look very similar. Public, float, vertical axis. Here you go. Oh, what did I call it? Vertical axis. I apologize, guys. Vertical input. There you go, semicolon. And I'm going to do the same thing. Line 22, press return twice, and I'll just say vertical input equals. And we know that the name, based on our project settings, was axis. I cannot spell on this. This new Apple keyboard always gets me. Vertical. I'm going to leave some comments here for myself. Finding the number or the float that is connected to the up and down controllers. Okay, save that. And I need to use vertical input in my move forward. So I'm going to go here, multiply, vertical input, save that script. So now I should only move forward when I use my up and down keys. There you go. And I'm sliding, but we're going to fix that in a second, and I can move forward. Very, very simple player controller script here. I'm going to get out of play mode, and let's fix that rotation thing. Since we never want to change this in the inspector, I'm going to change these to private. We just had them there so you could see them. There you go. Save that. To rotate, line 29, it's going to look very similar. Transform dot rotate. And this needs a different art. It needs to know which axis we're going to rotate on. Now, since we're moving left and right, I'm just going back here and let you see it. If I'm rotating left and right, I want to rotate on this Y axis. So that's going to be, the axis I want to be is the vector 3 dot up, because Y is what the axis that goes up and down. So inside of my rotate argument, vector 3 dot up. And this one looks a little different. It has a comma. So you'd say the axis. You see right here it says axis and comma. And then it wants to know how much do we want to turn. Well, we already have a float to do that. So turn speed, shift 8, so multiply by time.delta time. And then we still want to multiply, since like our right controls, we want to use the horizontal input. We want to make sure we only turn when we press the key down. So horizontal input. And save that. And you know what I'm going to do? I'm going to have my rotating my player left and right. All right, now I save my script. So we're going to press play. And now I should rotate as well. Not perfect, but it feels a little more like natural whenever you're moving forward. This is a very basic player controller, but we will be doing more in the way of controllers, of course, that shows up whenever I'm trying to do something. So yeah, guys, we covered a lot in here. We went back, we talked about variables, the different types of ones that we have, what a transform.translate looks like. We looked at vector 3s. We explained what updates look like, late update, what time.delta time is. We looked at axes and how to get player controls using input.getAxis. We talked about 2 ways to move our vehicle, which would be using the rigid body. We could use a rigid body. We didn't do that for this game. Instead, we used the transform, which is not the way you typically would do this. We talked about how to name our scripts, no spaces, capital, capital, and how to name our variables, which is camel casing, lowercase for the first one. Everything else is uppercase for the next sequential words and no spaces. And we talked about methods. We talked about this is where the action happens, and you need to be inside of these brackets. And finally, we looked at semicolons. And this is our first little project. It's not overly complicated, but I'm hoping you feel like you've learned a lot from this. And I will see you in our next Create with Code project.